Hello everyone, this is Fahad. So today's class will be about General Physics Section A, Unit 2. And the title of the chapter is Speed, Velocity and Acceleration, which is a very fundamental knowledge about physics. So to understand this chapter, we need to know some very informative and important things. Speed, velocity and accelerations, and there are some other things in this unit, so I shall be explaining these things chronologically later on. But in this class we will be explaining about what is speed, what is average speed, what is velocity and what is average velocity, and last of all what is accelerations. So in case of understanding these things, we need to know that in our previous class I explained that the quantities are fundamentals and derivatives. So in case of derived quantities, we know those quantities are depending on fundamental quantities. But there are some other types of quantities like scalar quantity and vector quantity. Scalar quantities are those actually have the only magnitude. So there are two different things which need to understand. Number one, magnitude and directions. So magnitude and directions, what are those? To understand speed and velocity, we need to know that speed is a scalar quantity and the velocity is a vector quantity. Like if I say a car is moving eastwards and it crosses like 3 kilometers to eastwards. So it comes from here, if I just say it's point O and this is A, if it comes 3 kilometers from O to A, that means in eastwards, and again took a U-turn and come to westwards into 2 kilometers. Suppose, so this is east and this is west. So if a car moving to A or eastwards at 3 kilometers and took a U-turn and come again 1 kilometer, and now if we want to measure what is the distance and what is the displacement, we need to think about these two things, magnitude and directions. So if we see the first time it moved 3 kilometers and then again when it took a U-turn, then it again crossed 1 kilometer. So it altogether 4 kilometers. But if you want to know the displacement, then we know that when it crosses in one direction 3 kilometers and again crossed 1 kilometer in the opposite directions, so the displacement is the linear distance from the previous one, the last one. So the displacement would be only 2 kilometers. So previously it traveled 3 kilometers and then it moves backwards 1 kilometer. So the displacement would be 2 kilometers. So it means in case of understanding speed and velocity, we need to know what is the distance and the displacement. So the distance is a length covered by any moving object. Irrespective of directions, only the magnitude is important of. So when magnitude is important, then direction here in case of understanding the distance, we need to know it has only magnitude but no directions. Suppose if I give an example like, okay, so this is very important. So if a very important thing like a car is moving here from O to A, which is 3 kilometers, and again it moves from A to E having a perpendicular line, it's 90 degrees from again 3 kilometers. So we can say that a car is moving from O to A to B. The total distance covered 3 kilometers plus 3 kilometers, it means 6 kilometers. But if you want to know the distance, this 3 kilometers just joined. But to know the displacement, we need to join these 2 points and to find this value. How? And we know the Pythagorean theorem that OB is equal to root OA square plus AB square. So the displacement would be O to B, and it would be 3 square 9 plus 9, so root 18 meter. So hence, in case of understanding the displacement, we need to know the direction. So the direction will have magnitude, so the displacement will have the magnitude and also the direction. So to understand speed right now, we know that speed is the distance moved divided by time taken, or we can say the distance is the length covered by a moving object over the time, or unit time, or per unit time. So in case of understanding the speed, we must know that speed is expressed by v, though the velocity will be expressed by v also, but in case of speed it would be the distance covered by time. So the distance covered or distance moved by time would be the speed, and it has no direction. It's a scalar quantity. And in case of understanding the velocity, we need to know that velocity is the displacement, because it is the vector quantity. It has a certain magnitude and also a direction. So in case of displacement, we need to know that this is s divided by time taken, and we know that time taken is expressed by t. So the unit of speed and velocity are same, because both are the length, and we know the unit of length is meter, so it would be meter and second, and this is also meter per second. So the unit of speed would be meter per second and also meter per second. But in some cases we can see that the unit can be given by kilometer per hour. So on that level we need to convert it kilometer per hour into meter per second, because doing the calculations in physics mathematics, we need to know that SI unit should be counted. So as SI unit, the standard one, so we know that when any sort of unit in case of speed and velocity is given kilometer per hour, suppose is given like 108 kilometer per hour is given, we need to convert it into meter per second. How? We know that 108 kilometer per hour means 108 kilometer over 1 hour. So if we need to convert it into meter per second, we need to convert this 108 into meter. So it would be 108 into 1000, and 1 hour is 3600. So if we divide it, so we'll have 1080 over 6. So it would be like a calculator here. So it would be 1080 divided by 36 is 30 meter per second. So this 30 meter per second would be the value if it's given 108 kilometer per hour. So this kilometer per hour, if it's given, we need to convert it into meter per second. So in case of speed, we know that speed is measured by the distance moved over time taken. But in case of average speed, why this word is being used, average? Because suppose an MRT train is moving. So when it's moving, it was started, the initial velocity that is expressed by u was 0. Suppose it started from 0 and then it moved few minutes. Suppose if I say that it moves for 10 minutes and then after it becomes suddenly a halt. So if I say that it suddenly comes halt, then the velocity, the final velocity would be 0. So again we see that the initial velocity was 0 and then it was started, and then it moved from here to here for 10 minutes, and then after it's just getting halt, and then the final velocity is getting 0. So in the meantime, it definitely traveled certain amount of roads. So it means, what is the value then? I can see the initial velocity is 0 and the final velocity is 0, but here the time is only 10 minutes. So this 10 minutes is all about like 600 seconds. But what is the velocity then? So if we need to know the average speed, we need to count the total distance moved. So if we say that the total distance moved by the car or the MRT train is 5 kilometers. If I say the distance from here to here is 5 kilometers and it traveled in 10 minutes, so here the unit, we need to convert it into meter per second. So the SI unit of speed or average speed or even velocity or even average velocity should be meter per second. So if we say that the MRT train traveled in 10 minutes in 5 kilometers, so then we need to convert it, this 5 kilometers into meter, and then this 10 minutes into 600 seconds. So if I divide, we find 50 over 6 meter per second, and this is the average speed of the train. Though we say that it started with 0 and suddenly halt, the velocity is again 0, but we know the distance traveled is 5 kilometers over 10 minutes. So within 10 minutes we know the total distance moved is 5 kilometers and total time taken is 10 minutes. So we divide it and we got the average speed. But in case of velocity, we need to know what is displacement. So the magnitude and the direction is important, and the total time taken. So if we say that in your book there was something is given like some moving object like Earth rotating around the Sun is 30,000 meters per second. 30,000 meters. So the directions, the movement of Earth is moving around the Sun is 30,000 meters per second. And again, it's Boeing 747 Demon, it's 300 meters per second, like nearly the speed of sound. And again, a car is 16.7, even MRT train is 12.5 meters per second. So on your book is written. So in case of understanding the velocity, we need to know the displacement, and in case of average velocity, the total displacement by the total time taken. So if we think about the acceleration, the last one, so if I should erase this right down here. Okay. In case of acceleration, it expressed over a. So we need to know that what is the changes in velocity. So we will explain it or express it over del v, and the time taken is del t. So this delta sign is expressed as like what is the changes in between the initial velocity and final velocity. So in case of initial velocity, we need to know that it expresses through u, and in case of final velocity, we need to express it by v. So as we know that it started to u and ended up at v, suppose a car is moving from 2 meters per second to 10 meters per second in 5 seconds. So in our 5 seconds, the velocity has changed. So if velocity changed per time or per unit of time, we need to know either it increased or decreased. In both cases, the changes of velocity over time would be counted as acceleration. Either it can be positive accelerations or even it can be negative acceleration, which is retardation or deceleration. So in case of acceleration, we know the final velocity and the initial velocity would be different. Suppose it started with 2 meters per second and ended up with 10 meters per second. It clearly shown that the velocity increased over time. So over time, if we say that it's 10 minus 2 over 5. So it would be 8 over 5. And the unit would be meter per second square, or meter per second per second. How come? Because the velocity changes of velocity, as we know. This is the change of velocity over time. We know the unit of velocity is meter per second. Meter per second, again the time, so it will be again second. So the velocity, the acceleration unit, that would be meter per second, or even we can write ms inverse 2. So here 8 over 5 would be ms inverse 2. So the acceleration is the change of velocity over time taken. So definitely there will be a time taken, and the changes of velocity, either that there is a change in positive way or negative way. Like negative way, suppose a car moving at 20 km per hour, and suddenly it saw a pedestrian over there, and then it getting hot and getting stopped. If it gets stopped and the velocity is 0, it means the changes of velocity are not positive, it's negative, because it's broke down and pushed the car, and then it getting 0 here within, like, suppose 2 seconds. So what would be the, suppose it's 20 km per hour, or you can write as 20 meter per second. So the acceleration would be those changes of velocity. Like it was 0, I mean it was 20 meter per second, and right now it's getting 0. So it will be 0 minus 20 over 2 seconds. So definitely we got a minus here. So that will be minus 10 meter per second per second. So that is minus, that expresses that this minus shows this is actually the retardation or deceleration. So in case of understanding the retardation and deceleration, we need to know the final velocity would be less than the initial velocity. So in this class we need to know about these 5 things. In case of speed, we need to know total distance covered over time taken. In case of understanding the speed and average speed, it's all about total distance. In case of average, in case of only speed, we need to know the distance moved. Velocity, it's vector quantity, it has magnitude and direction. And also the acceleration is changes of velocity over time taken. So this is a very simple and primary level class of general physics. I shall be explaining, and you know that there are lots of mathematics is coming to you, and this sort of mathematics we need to know, we need to understand what's written on the question and what is the insight. Then we can do the situational analysis of the state or something is given, what are the situations, and then we can have the calculations correctly. So see you on the next class regarding the time velocity graph, and later on I'll be explaining the consequently the next part. So see you on the next class. Stay well, stay happy, take care.